Solving linear inequalities. Our objective is to graph and solve linear inequalities in two variables. Who uses this? Consumers can use linear inequalities to determine how much food they can buy for an event. Let's start with some vocabulary. A linear inequality is like a linear equation, but the equal sign is replaced with an inequality symbol. The solution of a linear inequality is any ordered pair that makes the inequality true. So let's practice that part. We're going to identify solutions of inequalities. We're going to tell whether the ordered pair is a solution. So to do so, we need to plug the values in. We have our x, y coordinate, so 7 is going to replace our x, and 3 is going to replace our y. So 7 minus 1 is 6, and 6 is in fact greater than 3. So yes, this makes a true statement. So now let's try B. Once again, we have an x, y coordinate, so we're going to replace our x values with 4. So we have 3 times 4 plus 2. And we're going to replace our y values with 5. And that's an inequality symbol, not a 7. Sorry about that. Okay, so now we have 3 times 4 is 12, plus 2 gives you 14. 14 is not less than 5, so no. This coordinate does not create a true statement. Now let's look at some of the pieces we need for graphing. When the inequality is written as y is less than or equal to, or y is greater than or equal to, the points on the boundary line are solutions of the inequality, meaning those values will make a true statement. So it's going to be a solid line. If you have y is less than or y is greater than, you don't get to include the values that are equal to y. So that's why it has to be dashed. So recap, when it's less than or equal to or greater than or equal to, it's a solid line, just like we've done in the past. When it doesn't have the little equal to, it's going to be a dashed line. And now we have one more step. We have to shade. So when y is greater or greater than or equal to, you're going to shade above. You can think of it this way. Y is bigger. So where is y larger? Well, it's larger above, so that's why you shade above. The opposite is correct as well. So when the inequality is written as y is less than or equal to, where on the graph is y smaller? Y is smaller below, so you would shade below. There are 3 steps when graphing linear inequalities. Step 1. Solve the inequality for y. This puts it in slope-intercept form, something you're familiar with when it comes to graphing. Step 2. Graph the boundary line. So that's when you're going to just graph that equation. Now, when you do so, you have to decide whether it's going to be a solid line or a dashed line. And then in step 3, that's when you shade. Do you shade above or below? So now let's try graphing linear inequalities in 2 variables. Step 1. Get the y variable by itself. It already is, so step 1 is complete. Step 2. Draw in your line. So are we going to have a dashed line or a solid line? We look at this inequality symbol. Well, since it doesn't have an equal to, it's going to be dashed. So we start at 4, and we rise 3, run 1. Because remember, this is like saying 3 over 1. You can also go down 3, and then to the left 1. and then you would draw in your dashed line. So step 2 is now complete. Now we need step 3. We need to decide which side we're going to shade. Y is less than. It's smaller. So where is Y smaller? Below or above the line? Well, it would be below the line, so we're going to shade below the line. And there you have it. Let's try another one. Step 1 says to solve for Y. Y is not by itself in this one, so we must solve for Y. So we're going to subtract 3x from both sides, which leaves you with 2y is greater than or equal to negative 3x, and since it's a positive 6, plus 6. One more step, divide by 2. So we have y is greater than or equal to negative 3/2 x plus 3. Now we're on step 2. We're going to graph the boundary line. So start at 3, and then go down 3 over 2, down 3 over 2. So remember, it's rise over run. And then, is it a solid line or a dashed line? Well, it has that or equal to, so it's going to be a solid line. And that completes step 2. Step 3, we need to shade. So if y is larger, you're going to shade above. Y is smaller, you shade below. Well, in this case, y is larger, so we're going to shade above. If you're worried that you shaded on the wrong side of the line, you can always double check. So I like to double check with 0, 0. So let's look at our origin. So when we plug in 0 into both our x and y, we end up with 0 is greater than or equal to 6. Does that work? No. So therefore, we shaded in the correct place. If we had shaded here, then that would have been a possible answer, and it's not. Now let's practice writing an inequality from a graph. So we're basically just going to go backwards. To do so, you need a couple of pieces of information. You need your y-intercept, and then you need your slope. So your y-intercept in this case is 2, and then your slope. You go down 1 over 3 and you meet a nice point. So your slope is negative 1/3 because you go down 1 over 3. So now, just like when we were writing things in y equals mx plus b, you're going to do the same thing here. However, it's not going to be an equal sign anymore. So let's start with the pieces that we know. So we have y, and then our slope is m, so we have negative 1/3 x, and then your y-intercept, so plus 2. Now we need to decide what symbol to use. Well, it's a dashed line, so we know it's got to be either less than or greater than. And we're shading below, so that means y has to be smaller. So less than makes y smaller. Let's try another one. So just like before, we need a y-intercept and a slope. Our y-intercept is negative 2. That's where it crosses the y-axis. And then the next nice point we have, so we're going to go up 1, 2, 4, 5, and then we're going to go over 1. So 5 over 1, which you can write as 5. So now we have our y equals mx plus b, only our equal sign gets replaced. So we have y, and then our slope, mx, and then we've got plus our intercept, so negative 2. And now we've got to decide, which symbol are we going to use? Well, it's a solid line, so you know it has to be an or equal to. And then it's shaded above, so that means y is bigger. Which one puts y as bigger? The greater than or equal to, so that's the one you use. This one's a little tricky. When you try to calculate your y-intercept and your slope, Do you have a y-intercept? What is your slope for this one? Well, you don't have a y-intercept at all, so that's just none. And then your slope is undefined. So when this happens, you know that it can't be a y is equal to. It's going to be an x is equal to. What are all your x values equal to in this? Well, all your x values for the line are going to be -2. So now we just need to replace our equal sign with an inequality symbol. So we keep our -2 in our x, and now we think of it in terms of x is bigger or smaller. So it's a solid line, so you know that it has to be an or equal to. Think of it in terms of the same philosophy that you did for y. Where is it shaded? It's shaded to the right. Is that when x is bigger or smaller? Bigger. So where is x bigger? It's when it's greater. Now let's try a consumer economics application. Sarah can spend at most $7.50 on vegetables. Broccoli costs $1.25 per bunch, and carrots cost 75 cents per package. Write a linear inequality to describe the situation. Well, the cost of broccoli is $1.25, so $1.25 times x, because it's for each bunch, plus our carrots are 75 cents per package, so that's times y, and Sarah cannot spend more than $7.50. So now we want to solve the inequality for y, because that's what's going to help us graph the solutions. If we multiply everything by 100, it's going to move our decimal point over 2 places, getting rid of the decimals. So that would leave us with 125x plus 75y is less than or equal to 750. Keep in mind, if you're going to do that, you can't just do it to one number. You have to do it to everything, so that way everything stays on an equal playing field. So now we can go about solving for y. So we're going to subtract 125x from both sides, leaving us with 75y is less than or equal to -125x plus 750. And now we can divide by 75. Remember, you have to divide the entire side by 75, not just one of the numbers. So we end up with y is less than or equal to -5/3 x plus 10. So we start at 10, and then we go down 5 over 3, down 5 over 3, and now we draw our line. It's going to be a solid line, and then we're going to shade below. So there's your graph. Now what if we were to pick a couple possibilities for solutions? Anything in the shaded region, or in this case, on the line, is going to be a solution. So Sarah could purchase one bunch of broccoli and 4 packages of carrots and spend less than $7.50. She could also pick up 3 bunches of broccoli and 3 bunches of broccoli and 5 packages of carrots. Anything in the shaded region is a solution. Anything out here is not a solution. And that ends our video lesson on solving linear inequalities.